Welcome to the Scorpene subbrief. Today we're going to talk about one of the most popular export submarines in the world right now. 11 of these Scorpenes are built and operated by 4 different navies, all in the southern hemisphere, ironically. So if you're operating in the South Pacific, South Atlantic, or the Indian Ocean, there's a chance you may come across one of these. Now, because they're operated by 4 different navies, each variant for each country is a little bit different in terms of equipment, and we'll be going over all those individually. Some things that the submarine Scorpene-class share amongst all of them are the 6 torpedo tubes that it operates, a very capable sonar system, and the MBDA Exocet cruise missile Block 2. The very first of these Scorpene-class was commissioned in 2003 for the country of Chile, but since then they've been exported to India, Brazil, and Malaysia as well. Scorpene-class is a joint venture between France and Spain and their respective military industries called Naval Group for France and Navantia for Spain. So they're built in those 2 countries as well as the countries that are operating them. Here are the countries that received the export version of the Scorpene. On the left we have Chile. They have the O'Higgins and the Sarara. Malaysia operates 2, the Tunku and the Tun Rask. India operates 5 of these, and Brazil operates 2 of these, the largest of which has been exported to Brazil. Theirs displaced the most water. So let's begin with the sensors here. They all have the SAGM I-band navigation radar on the mast, but Malaysia and Brazil operate the Talos DR ESM electronic support measure equipment. Chile has gone with the slightly less expensive AR900 ESM system. For sonars, they use the Talos S-Cube sonar suite. The reason for that is a modular sonar suite. You could have one array, you could have multiple arrays that cover 360 degrees of coverage around your submarine. It is up to the Navy and the country to determine what version of the S-Cube sonar suite do they want. Included with the S-Cube on this submarine is the TSM 2253 Planier Flank Array, which is a fantastic flank array that goes down the port and starboard sides of these submarines. As far as countermeasures go, India has spared no expense and has gone with the Leonardo C303 torpedo decoy launcher, and Brazil has employed the hard kill anti-torpedo system called Contralto S. And I'll show you some pictures of how those work. That was an extremely secret program when it was in development, but now that it's in operation, it's some information's come out about it, and we'll talk about what we can. They all shoot the Exocet Block 2 anti-ship missile from the bow, and they fire either the heavyweight F-21 French torpedo or the Black Shark heavyweight torpedo made from Italy. And Malaysia and Chile shoot that Black Shark torpedo. Here's a list of all the ships and when they were commissioned. As you can see, they are manufactured at multiple different sites. India builds their own in Mumbai. Brazil builds their own. And there was a time when Brazil was fooling around with the idea of making the S-40, the Richelieu, a nuclear-powered submarine. But since it's been commissioned in 2022, and I have no further information on them trying to make it nuclear, I assume that it is still a conventionally powered submarine. But that's an interesting little twist to the S-40, one of 2 that Brazil operates here. So even though these are made and designed by France with Spain engineers as well, they are built in Cherbourg Naval Group in France and Cartagena Navantia in Spain. India builds their own out of Mazagaon shipbuilders. And I want to pay note to the picture in the lower left. You can see the Indian flag covering the flank array going down the side of the submarine there. That's where that flank array goes. And Brazil has their own small shipyard where they build and maintain their 2 submarines. All right, so the Scorpene-class by the numbers. This will be a little confusing because there's 4 different variants here. So I've tried to simplify this. Malaysia and India use the peel stick 12-cylinder marine diesel. They have 2 of those. If a country's not operating those two peel sticks, they will operate 4 of the smaller MTU Rolls-Royce 12V 396 engines. Those are physically smaller, so they can put 4 of them on, and they produce 4 of them produces the same amount of power as 2 of the larger peel stick ones do. So it's a 1-to-1 push, just different countries went with different layouts for their marine diesels. So I should mention that the Cavalry class did intend on having air-independent propulsion installed on at least one of their Cavalry class submarines. That went horribly wrong, but I believe that they still intend on doing that. So there's a potential that at least one of India's 5 that they operate is air independent, but that has not been confirmed as completed yet. So that's still out there as a potential. They could easily change their mind and just leave it diesel electric like it should, like it's been designed to be. But there's possibility of one being air independent. So max underwater speed is 20 knots. On the surface, it can make 12 knots. And it has a 6,500 nautical mile range at 8 knots. And that would be 8 knots surfaced, by the way. Okay, it can shoot 18 weapons. So it shoots either a heavyweight torpedo or an Exocet missile. It could have 18 Exocet missiles, or it could have 18 torpedoes, but not both. So each submarine has weapon stows for 18 weapons. It does have 6 torpedo tubes. Those are 53 centimeter torpedo tubes, which means that they can shoot all the NATO ammunitions, whether it's the Spearfish, would physically fit in their torpedo tube. And as well as the AdCap. They just don't have the software to launch those types of weapons, presumably. But the fact is that the hardware can physically shoot those weapons. So a software install wouldn't be that much of a difference. It would be a huge upgrade in capability, but it's not that hard to do. I-band navigation radar are on all of them. It's a standard SAGM navigation radar. The Talos S-Cube sonar system is really interesting. We'll get into that here in a second. That's coupled with the flank array that I talked about. When you do that, you make your submarine extremely valuable. It can see a very long way across the oceans. The Leonardo, which is the Italian version, C303 torpedo decoy launchers, is operated by India. And then the Contralto hard kill torpedo defense system is operated by Brazil. Talos DR3000 ESM, or electronic support measure, is operated by Malaysia and Brazil, and the AR900 electronic support system is operated by Chile. UDS is the International Subsonic Weapon Control System. Basically, it groups all the sensors to the fire control system, including radar and communications. It's basically the heart of the submarine, linking everything together and making it usable to the operators and understandable to the officers. Here's that peel stick marine diesel. This one's operated or manufactured by MAN Diesel Group. It's very large compared to the other submarine diesel engines, but this makes a lot of power. It makes just under 2,000 kilowatts running at 1,500 RPM. Very fuel efficient, water cooled. IOC'd all the way back in 1962, and it's still used today on brand new submarines because it's such a great, efficient, low maintenance, low cost design. If you can fit this on your submarine, most countries go with that. But if you can't, for whatever reason, you don't have the floor plan for that large diesel, you can get the smaller Rolls-Royce marine diesel called the MTU 12V. And this comes in different configurations. You can get the 8V, the 16V. Those are all different cylinders, but they're all in a V configuration. And each engine will produce 12 kilowatts at 1,800 RPM. That's why they have 4 of these, so they can get up to 4,000 kilowatts, just like the submarines operating the other diesel engine with only 2 can produce 4,000 kilowatts. But again, the service time on this is very low. It's very easy to maintain, and it doesn't require much once it's up and running. This IOC'd in 1990. All right, here's the S-Cube sonar system by Talos. This is modular, which means you could have one of these arrays or you could have all of these arrays. It is a combination. It's like Legos. So up front on the bow, you're going to have a conformal array or you're going to have a cylindrical array. You could even have both if you have the room for it, but you wouldn't really need both. That's going to give you 360 degrees coverage of everything in front of you and to the sides. But you will have what's called a baffle region where it literally can't see through the submarine behind it. So that's why you have these other arrays. The flank arrays that run down the side are extremely good. And because you have one on the port side, one on the starboard side, the flank arrays alone will give you 360 degree coverage because the beamformer combines those two flank arrays into what is digitally a large sphere all around the submarine. So those are key and are on every single one of these submarines. Now, something that's very optional because of the flank arrays is a towed array. And you have every possible towed array option you want. You can have a clip-on towed array, which means when your submarine leaves port every single time, it's followed by a tugboat until it gets into a little bit deeper water. And then they physically clip a towed array onto the back of it that's strung out 500-600 feet. And then you go to sea with this towed array behind you. The problem with that is when you return to port, that tugboat has to meet you in deep water, find that towed array, fish it out of the seas, and unclip it from your submarine before you can pull in. Otherwise, you'll be dragging it through the mud, destroying the towed array. That's a real maintenance pain. That's why most people go with the reelable towed array if they have the space for it. That's usually stored inside a ballast tank, the entire kit, the winch, the motor, the towed array, stowage drum itself. If they have room inside an aft ballast tank, they'll usually go with that one if they have a towed array at all. Now, as far as the towed arrays go, they can have passive towed arrays and active towed arrays. They can have a towed array that pings active, and then they use the rest of the sensors to get a bearing off that ping. Very multi-function, literally, sonar system. The S-Cube is designed to be very flexible and fit on any submarine from 500 tons, which is very small, to 3,000 tons, very large. Here's the plan of your flank array, and each one of these panels you see the technicians bolting on is very good. It's long range, it's sensitive, it's wide frequency bands from 0.003 hertz, very low, all the way up to 10 kilohertz. And then when you pair it with a second one, and a third, and a fifth, and a 10th, and a 12th, you get incredibly accurate bearings at very long range. This is a fantastic array. This array alone, in my opinion, supersedes every other array they have from the S-Cube sensor system, which technically is a different system. This TSM 2253 Planier Flank Array technically is not part of the S-Cube system, but it is paired with it because it is a nice pairing of conformal and towed array with this flank array, giving these submarines outstanding sonar performance. They can track up to 64 targets with the combat system, and 8 are an auto track, which means you assign a tracker and just let it go. It'll track the target left, right, and as it goes up and down. All right, here's the torpedo decoy launchers. We're going to start with the C303. This one's manufactured by Italy. Their company is called Leonardo. Basically, the military industry complex owned, well, it's a multinational company, but it's stationed out of Rome. So they identify as an Italian company. This is on the Cavalry class, the ones that are operated by India. It's an anti-torpedo countermeasure with a very strong active and passive sonar decoy capability. It also has a jam mode. It can lure a torpedo to it and then confuse it, or it can just jam and insonify the entire stratosphere of water with noise, confusing the torpedo as to where the target might possibly be. The torpedo will have to keep restarting its search because it can't see anything, much less a target. It's pretty effective. Little system. This I'll see it in 2000. Now, the Contralto S torpedo countermeasure, this entire program was super secret forever because it is a hard kill system. This torpedo decoy system will not only do what the other ones do in terms of jam, decoy, and lure torpedoes away from your submarine, it will also physically ram the torpedo, destroying it physically. It's a hard kill system capability. And it's demonstrated to work, which is a very difficult thing to do. Now, how it does all that, of course, is still not public, but this one is special. The Contralto S torpedo countermeasure is a very new technology. Of course, NATO uses it. DR3000 ESM, that's electronic support measures, ESM. I get that question a lot, so I want to make sure we make that very clear here. This is different than ECM, even though they commonly work together. ESM is just passively recording the data and analyzing it. So this covers NATO IJ bands of radars. It has the large antenna that you can see there coming up on a mast, 360 degrees of coverage, and very sensitive. Anytime you see a sensitivity of more than -60, that's kind of the threshold between amazing and awesome. So this is an amazing sonar system, or radar detection system, very sensitive. This IOC'd in 1991 and was installed on these as early as 2007. So Hull 1 didn't get it, because Hull 1 got this. The Chile export got the AR900 ESM from Argo Systems. It's a radar electronic support measure system. This is a kit that you can put on anything. And in this case, they put it on a submarine. It fits rack mounted with one display, one computer, and a keyboard, as you see here. And it has multiple sensors that you can stick, in this case, on a mast and send it up with your periscopes. And it will just automatically search. Can track up to 500 contacts. It will classify the contacts by their frequency, what kind of radar it is, how powerful the signal strength is, and its PFR rate, how fast is it updating, because a fire control radar, for example, or an interrogation radar would update extremely fast, multiple times a second, whereas a standard search radar just sweeps regularly a lot slower. And this will give you information like that on a budget. All right, here's the F-21 heavyweight torpedo manufactured by Naval Group. This is a very large, nearly 3,000-pound weapon, but it is electrically driven, which is quite unique. This is actually becoming more common. Today's batteries are so powerful, they can push heavyweight torpedoes, whereas decades ago during the Cold War, anything this heavy would usually have a thermal engine, a gas-powered engine, essentially. But this is pushed by a electrical propulsion and is connected with fiber optics, which means it has a high data bandwidth back to the submarine as it conducts its mission. This IOC'd in 2019, a very new and highly capable 50-knot long-range torpedo. The Black Shark heavyweight torpedo, essentially Italy's version of the same thing. There's a few minor differences in terms of performance, but the big thing is it can do 50 knots as well. It's 50 kilometers range, and the warhead is 250 kilograms. It's fiber optic. It is active passive acoustic, and has a cool black paint job instead of the French green paint job. But essentially, Black Shark and F-21 are, in my opinion, the same torpedo, built and operated by different countries. Here's the Exocet SM-39 Block 2 Mod 2. This is an old and well-tested but modernized and updated subsonic anti-ship cruise missile that uses a solid propellant propulsion to eject it out of the canister in this case, because it's submarine launched. And then it is an air-driven engine that drives it to the target. Its warhead is 165 kilograms, high explosive RDX. This IOC'd in 1985. And this particular Block 2 version was updated again in 2005. So modern, subsonic, anti-ship cruise missile. All right, the Scorpene-class, very well-designed export submarine. Even though the French build it, they don't use it because they have a nuclear-powered version of this class of submarine that they operate. They build this one and designed it to be export only. And that is part of the reason why Brazil wanted to try and make one of theirs nuclear powered, because the French had done it. But the French also designed it, and they know more of the submarine and how to do things like that than what Brazil knows. And there's a story in there somewhere. I'm not sure where that story ends. So maybe I'll look that up and make a video out of that for you guys, how Brazil tried to make a conventional submarine nuclear powered. As far as I know, that's still ongoing too, so that story may not have completed yet. But back to the Scorpion, the conventional class. Brazil did order 2. India operates 5. Chile and Malaysia each operate 2. A total of 11 submarines are in use today. 3 more are being built. 3 more in the dry docks, on blocks, being assembled right now. And these are still in use today. They IOC'd in 2003, and they continue to operate, all in the Southern Hemisphere. And they are very good submarines. They're fast, they have a heavyweight punch, and one of the best sonar systems you can buy out there. Very impressed with the Scorpene-class. All right, that's been the Scorpene-class sub brief. Thanks for listening, everybody. We'll see you next time.